So one of the more unique uses of Fourier series is using them to sum up infinite series such as that posed in the Basel problem. And the Basel problem asks, what is the sum from n equals 1 to infinity of all the inverses of the squares of all the natural numbers? And the way we solve this is we're going to first take the Fourier series of f of t is equal to t squared, and we're going to define the period to be from t goes from 0 to 2. And so with that in mind, we're going to solve for that. So a sub naught is going to equal to 1 over 1 equal from 0 to 2 of t squared dt, which is going to equal to 8 thirds 8. Alright, that one was easy enough. Let's go for a sub n now. A sub n is going to equal to the interval from 0 to 2 of t squared cosine n pi t dt. And that's going to end up equaling negative 4 over n pi. Now we're going to find, no wait, I'm sorry, this is going to equal to 4 over n squared pi squared if you work it out. Similarly then, we're going to find b sub n. B sub n is going to equal the integral from 0 to 2 of t squared sine n pi t dt, which is going to equal to negative 4 over n pi. And so now we have our Fourier series defined as f of t is equal to 4 thirds plus 4 over pi squared, sum from n equals 1 to infinity, cosine n pi t over n squared, minus 4 over pi, sum from n equals 1 to infinity, sine n pi t over n. And so what we're going to do is we're going to find what f of t is going to equal to for 0. So f of 0 is going to equal, well, the actual value of the function for the Fourier series after infinite number of terms is going to equal to the half of the period. So since the period is 2, it's going to be going from 4 to 0, so the average of 4 and 0 is 2. So if the Fourier series is conducted infinitely, you will get 2. So 2 is equal to 4 thirds plus, it's going to be 4 over pi squared, sum from n equals 1 to infinity of 1 over n squared. And the sine term over here is going to equal to 0. So we have 2 equals 4 thirds plus 4 over pi squared, sum from n equals 1 to infinity, 1 over n squared. And now with a little bit of rearranging, 2 is just 6 thirds, so 6 thirds minus 4 thirds is 2 thirds. So 2 thirds times pi squared, 2 pi squared over 3, you'll get pi, divided by 4, you get pi squared over 6 is the sum from n equals 1 to infinity of 1 over n squared. And you can use this method for, say, summing up maybe just the odd natural numbers, the odd inverses of the squares of the natural numbers, or maybe just the even ones, or maybe you want to sum it up for 1 over n to the 4th. There's a lot of applications that you can do this for.